You probably know someone or have heard of someone who did everything right. They never touched a cigarette, never drank alcohol, maintained a perfect diet, and yet they still got a cancer diagnosis. Then there is the other end of the spectrum, the person who spent their entire life smoking a pack a day and drinking, who somehow sails comfortably into their 90s. Mathematically, it feels like a contradiction. How is this possible? Solving this paradox requires looking past the symptoms of illness to the microscopic math unfolding inside our own bodies. At its core, cancer is a statistical glitch occurring within your own biological machinery. Let's look at the sheer scale of that machinery. An average adult male is composed of roughly 36 trillion cells. Every single day, 330 billion of those cells die and are replaced. That is roughly 1% of your entire cellular makeup, turning over day in and day out. This turnover is incredibly fast. Your body sheds 500 million skin cells a day, completely replacing your skin every 4 weeks. And if you were to lose 90% of your liver, the remaining 10% could entirely regrow itself. Every time a cell divides and copies its DNA, there is a tiny chance for an error in the code, a biological typo. When you multiply that risk by hundreds of billions of replications every single day, the room for error becomes significant. The constant cellular regeneration that heals our wounds and keeps us alive is the exact same mechanism that puts us at risk. Think of your genes as a program with strict instructions. To prevent typos, the body has built-in defenses. It relies on security guard genes like P50 to repair damaged code. Filter genes trigger apoptosis, telling damaged cells to die. But when these defense genes fail, a mutated cell ignores the command. With no security guard, it copies itself uncontrollably. Eventually, these rogue cells infiltrate surrounding tissues. They break away from their starting point and spread to other healthy parts of the body, a process known as metastasis. To stop this, modern medicine often relies on chemotherapy. It is a powerful chemical override, but it is indiscriminate. It targets cells that are in the middle of division, meaning it attacks the fast-growing rogue cells, but it also destroys fast-regenerating healthy cells. This collateral damage is why patients experience severe hair loss and digestive issues. Crucially, chemotherapy also destroys the bone marrow, the tissue responsible for producing healthy red and white blood cells. Enduring this process requires physical resilience, like maintaining a strict exercise routine, even on days when receiving treatment. Chemotherapy effectively shuts down the production line for white blood cells and platelets. Within days, the body's existing blood supply begins to deplete, with no internal way to replenish it. So, if a patient's healthy blood cells are wiped out by the treatment, how do they recover? The answer lies in stem cells, blank slate cells that can evolve into whatever blood or tissue the body needs, a complete biological reboot.
Take the real-world case of a young boy named Chirag, who needed a healthy infusion of these cells to survive. His life was saved by Roman, a precision mechanic from Germany, who was found through the global DKMS registry. Connecting Chirag and Roman required matching a highly complex immune system marker called the human leukocyte antigen, or HLA typing. This visualization shows the massive genetic hurdle of finding that donor. The probability of a perfect HLA match with a complete stranger is roughly 1 in 100,000. If you are that one perfect match, the donation itself is remarkably straightforward. Through the peripheral blood stem cell method, blood is routed from one arm through an apheresis machine, where the stem cells are filtered out. The remaining blood is safely returned to your body in a simple 4-hour procedure. Modern medicine relies heavily on complex chemical treatments. Yet, in the fight against blood cancer, the most vital resource is the willingness of ordinary people to step forward and share their genetic code. This brings us back to our initial question: why do seemingly healthy people get sick? The first reason comes down to inheritance. 5 to 10% of all cases are driven by mutated genes passed down directly from parents. This chart shows the second major factor: age. As time passes, our genes wear out and accumulate damage. You can see the incidence curving sharply upwards here, with the maximum risk hitting between the ages of 85 and 89. We cannot change our inherited genes, and we cannot stop aging. But a 2017 analysis by the American Cancer Society revealed that 42% of all global cases are tied to lifestyle choices, meaning they are entirely preventable. 19% of those cases are caused by smoking, which damages DNA across 16 different types of cancer. Another 5.6% are directly linked to alcohol consumption. Carrying excess weight is a massive, often overlooked risk factor. Obesity alone is responsible for 7.8% of global cases. Then there is UV radiation. Nearly 5% of cases originate when ultraviolet rays penetrate the skin and directly damage the cellular DNA, a risk we regularly normalize with tanning and severe sunburns. Finally, exposure to environmental carcinogens, like asbestos, benzene, and certain food dyes, adds to the tally, along with preventable viruses like HPV and hepatitis B. We have zero control over the genetic code we were born with, and we cannot freeze the clock on aging. However, we wield immense control over the daily variables that push our cells to mutate in the first place. Cancer represents a devastating internal failure of the cellular regeneration that keeps us alive, but it is a failure we can actively guard against. By making smart lifestyle choices, we protect our own internal code. And by registering as stem cell donors, we can act as the ultimate biological failsafe for others. Like, share, and subscribe.